My next guest works on the team here at Microsoft that is transforming entire industries with its AI and machine learning-based solutions. I'm joined by Director of Program Management for the Cortana Intelligence Suites. Lance Olson is here. Lance, thanks for being here.
Thank you. My pleasure.
This is fun. All right. Now, first, we like to throw out a poll question to our audience so that we can have them weigh in on these topics. We'll reveal those results. Our next poll question, here it is. Which of the following do you think is best measure of data-driven organization? A, growth in the business, for example, market share increase. B, increased customer satisfaction. C, rate of experimentation on data. Or D, growth of data. Lance is going to share the right answer with us in a little bit here. But first, we're going to jump into the questions here, talking about artificial intelligence, machine learning. For those who are not familiar or have heard of it from the movies, what is artificial intelligence?
Yeah, so let me talk about artificial intelligence and machine learning together. Yeah. So first, machine learning is really a change in the way that we process information, the way that we write programs, computer programs. So we used to write programs where we would tell a program exactly what to look for, a particular result, and then take an action based on that result. With machine learning, what we do is we actually teach the program to look for patterns in the data, and then we feed it the data, and then it learns from the data that we feed it. It learns what patterns to find, and that allows us to find all kinds of, to solve problems that you can't solve with just a single answer. An example might be looking at the letter A written by a person. Every person might write that letter slightly differently, and so that's something that's very hard to have one exact answer to. Artificial intelligence, what we see is when we apply those machine learning techniques, especially to domains that are very familiar for humans, like speech or vision, then what we get is the ability to have machines that act more, they take on more human characteristics. And that's what we would end up calling artificial intelligence. And our view of artificial intelligence changes over time. Something that looks amazing and human-like 10 years ago, probably we all look at it now and go, well, that's not artificial intelligence. So it is relative.
And talk about why are we talking about these technologies today? Why are they so important?
Well, there are three trends that are driving a transformation in the world around us today that are behind this. One is the growth of data. I know you just talked about IoT, and the number of connected things that there are in the world are driving a massive explosion of the amount of data that we have to work with. And data is what fuels these algorithms and the insight, the intelligence we can create. There's also an increasing number of things that are born digitally, more data that's born digitally, and so we can actually easily get to the data and use it. The second thing is cloud maturity. As the cloud has come and become a mainstream technology, we're able to build systems in a different way. We don't have to design for the biggest scale on our own networks. We can actually design applications and then use the cloud, the elasticity of the cloud, to scale to much greater levels than we would if we were paying for all of that up front. So that allows us to bring a lot more computational resources to bear on the problem. And then the third area, and it's really an outcome or a cycle of the other two, is the maturity of the algorithms is getting better and better. So we're able to do things that we couldn't do before. An example might be, we've had speech recognition for a long time, but there's always that background noise, or maybe it's a different accent that throws the models that the algorithms we write off. And now we're starting to get much better algorithms that can handle all kinds of things. Might be the garbled sound of a voice coming in through a drive-through, but we can still recognize the speech on the other side.
Yeah, I want to talk a little bit more about how these technologies work, because as you said, once upon a time, artificial intelligence and these things were on TV shows and movies, and usually not even Earth-based, usually Star Trek and up in space, because in Earth we could never figure this out. Here we are, now we've got Cortana in our pocket, and we really can ask just about anything in the world and get intelligent responses. How does this technology work?
Well, it's funny because it has been, just working in this space, it has been somewhat surreal, the kinds of things that we see coming together. But fundamentally how it works is, if you take the example I gave about let's say that you're trying to write a program that recognizes the letter A. Well, one way to do that would be to write down the letter A, scan it in, and then tell a program, look, this is the letter A. Whenever you see this, you can say, I see the letter A. Problem is, the reality of trying to solve that problem is you'd actually have millions of people writing those characters, and everyone would be different. So what we do is we write a program that doesn't look for that exact answer. What it does is it looks for the patterns, and we feed it. We might feed it a million or hundreds of thousands of examples of the letter A, and it will learn from those. And then basically, once what it's doing as it looks at those is it finds the commonalities in those images, and it builds what we call a model that it can use, such that when we pass it another image, it can say, okay, that looks like the letter A based on what I've learned about that.
Mm-hmm. So let's talk about, and I know you've touched on it a little bit so far, but some of the practical applications of the technology, other than some of the fun stuff we all experienced on the consumer level, the novelty of, wow, I can ask her stuff and she answers, and she can give me directions and all, but talk about at large.
Yeah, so in Cortana Intelligence Suite it's the back-end brains that power a lot of the insight that we want to get in the businesses, and it's things like predictive analytics. So I want to predict when a machine is going to fail. If I have expensive machinery that's connected, could be an airplane engine or could be an elevator, I want to know well before there's any problem with it. I want to know about that. So predictive is a big thing that we see. Supply chain management, so being able to forecast my demand and know how much of each of the units I might be selling is going to be needed in a given area. The better I can forecast that, the more efficiently I can serve my customer and make sure that exactly what they want is what they get at the time that they want it. So those are very common things that we see, common use cases. Understanding a customer and being able to make recommendations that are relevant to that person, really having a deeper understanding of what people want as they use our products is another very common use case.
Artificial intelligence and machine learning as they're being infused into the workplace. I'm curious from your perspective what you're seeing, what you're hearing in terms of examples of how organizations have successfully implemented these technologies, because I would imagine at least once upon a time there was resistance because it is technology, and even the idea of artificial intelligence. And now I gotta be in control. I gotta be at the wheel at all times, and maybe a view of us versus them kind of a thing. What are you seeing in terms of successful implementation, and where can this go?
Yeah, I mean, I think the thing that really drives that change in the mentality to embracing these things is the results. If I can more accurately understand how my products are going to behave and better serve my customer, then that becomes compelling for people. So that Dartmouth Hitchcock example that you played as it came in is a great example. It's looking at how do we predict when people might need a certain medication or when they might need to come in for a doctor's visit so they can avoid that trip to the ER. I see this with folks like Rolls-Royce who do engines inside of airplanes, so engine maintenance, and ensuring that that engine is always in the best shape it can possibly be in order to run reliably and effectively is another common case, to be able to predict the behavior of that machinery and the behavior of the engine. We also look at cases like that to be able to give feedback to the pilots and help them understand. They're constantly making trade-offs about how efficiently they use the fuel versus how effectively they land the plane. And we can analyze those behaviors and the patterns and then give them feedback on how effectively they do that. Another customer that we have is Schneider Electric, and they do worldwide power management. So they have giant solar arrays that they use to power all kinds of different organizations, from cities to villages in remote locations. And they had a problem where they had dust that would come in and land on the solar arrays, and it would cause the solar panels to become less effective. And they didn't necessarily know if a panel had broken or it was just a dust storm. And so knowing the difference between, do I need to just send somebody out there with a squeegee versus do I need to send somebody out there with a repair truck, can have a massive impact on their cost, but also their ability to supply these people with reliable sources of energy.
The spectrum is quite interesting because, as you said, something from like a healthcare standpoint where to tie it into the mechanical side, as you said, almost our check engine lights. It's a way for us to have some indicators of when we might need maintenance as people and those sort of things. And I want to go back to the Rolls-Royce example you mentioned, because then we have a very cool visual to show the audience in terms of the augmented reality and what this looks like and how they're using it mechanically, like you said, with Rolls-Royce.
Yeah, in fact, one of the things that we're seeing is even the ability to combine things like HoloLens and augmented reality with analytics from Cortana Intelligence Suite. So we can actually visualize what's
And that's
happening.
what they're seeing here, right? That's obviously not there.
That's not there, but what you can see is how the information is flowing through the engine. And we can even overlay hotspots on that. So if you were actually out to, if you were a mechanic that was out to repair that engine, we could show you the most common areas of failure and even give you instructions on how to repair that engine based on the most common patterns that we've seen.
It's staggering. It's very cool and very exciting. Before we run out of time, I would like to reveal the results to the poll question. We threw that out to the audience.
Awesome. All right,
You're the only keeper of the actual answer. Which of the following is the best measure of data-driven organizations? Is it A, growth in the business? Maybe you chose B, increased customer satisfaction, C, rate of experimentation on data, or D, growth of data. And the audience says 40% of them chose B.
Increased customer satisfaction. Well, I would contend that both growth in the business and increased customer satisfaction are, while they're wonderful outcomes and they are examples of a result that we're achieving that's making our customers happy, they don't necessarily predict what's going to happen in the future. For that one is really it's focusing on transforming the way our organizations work so that we can have more experiments on the data, really drive that rate of experimentation up higher and higher and become increasingly data-driven in the decisions we make, because that allows us to see things, to use the machines to find patterns that we might not otherwise find.
Very exciting times. Keep it up. Thank you.
Great. Thank you very much.
Thanks for your info today. We appreciate it.